Example 6, Geometric Series. Part A. Find the sum of the first 5 terms of the geometric progression in which the first term is 27 and the common ratio r equals 2/3. Since the r is less than 1, so we have to use the formula with 1 minus r, bigger number minus the smaller number, so that we can get always positive for the Sn. And then by substituting a 27 and r 2/3 will be 227 times 1 minus 2/3 power of 5 over 1 minus r, which is in this case 2/3. And the answer is 71/3. Part B, the first term of a geometric progression is 27 and its common ratio is 4/3. Find the least number of terms when the sequence can have if its sum exceeds 550. So we are given the Sn equals 550, and then we have a equals 27 and also the r is 4/3. We have to find the value of n so that we can get the sum Sn exceed 550. So we got the idea here. We have to use the formula of Sn. Since the r is more than 1, greater than 1, so we have to use the formula of r minus 1, big number minus smaller number, so that the sum always positive. So we just have to substitute the Sn with the 550, a with 27, and then the r, the common ratio 4/3 power of n minus 1 over 4/3 minus 1. And then we have to simplify the equation. 550 multiply with the denominator here and then divide by 27 plus 1. We leave the equation as 4/3 power of n equals 631 over 81. Since n is the power of the index, so we have to log both sides. By taking log both sides, we will get n times log 4/3 equals log 631 over 81. And then we come to the last step for the simplifying. N equals to log 638 over 81 divided by the log 4/3. We get 7.136. Hence, Sn, the sum of the first n terms, must be greater than 550. Therefore, we require n greater than 7.136. Since n must be always an integer, a positive integer, therefore we conclude that n equals 8. Part C, calculate the sum to infinity of the series. We are given the series here, 2 plus 1 over 2 plus 1 over 8 plus 1 over 32 plus etc. The formula of the sum to infinity is as infinity equals a over 1 minus r. From the series, we can see that the first term a equals 2. So we substitute 2 here. And then we have to find the r, the common ratio r first by looking at the ratio between two consecutive terms. I take t2 divided by t1 here. With the t2 is 1 over 2 a half divided by the first term 2. So the common ratio is 1/4. And then substitute into the formula of S infinity. We will get 2 over 1 minus 1/4 equals 8 over 3. Part D, the sum to infinity of a geometric progression is 7, and the sum of the first two terms is 48 over 7. The 48 over 7 is the sum of the first term and the second term, T1 and T2. Or we can simply write it as S2 equals 48 over 7. Show that the common ratio r satisfies the equation 1 minus 49 r squared equals 0. So we have to use this information S2 and just compare with the formula of the Sn in geometric progression. So this is formula a times 1 minus r squared over 1 minus r equals 48 over 7. And then from the information earlier, we have sum infinity equals 7. So this is our first information to be the first equation. The second information will be the second equation. And then we have to simplify and solve these two simultaneous equations. Just substitute the first equation, a over 1 minus r, in this part, a over 1 minus r, to be 7 times 1 minus r squared equals 48 over 7. Simplify this equation, and then lastly we will get a quadratic equation as in requested, 1 minus 49 r squared equals 0. The second part, hence find the first term of the GP with positive common ratio. From the quadratic equation, we can see that the value of r will be positive and negative 1 over 7. Since we have to pick the positive common ratio r, which is 1 over 7, we substitute that value in the first equation in any two equations. So I choose the simplest one, the first equation. I will get the value of a equals 7 times 1 minus 1 over 7, which is equals to 6. Part A, express each of these numbers as the quotient a over r as a ratio. From a repeating decimal number, we have to convert this decimal number to a ratio or as a quotient. So we know that 1.6 is equals to 1.666. The 6 is repeating. I take out the 1 and then plus, make it as a series, 0.6 plus 0.06 plus 0.006, so that we can see the pattern of the series, and then we can choose the right formula in the arithmetic series or the geometric series. So from the bracket here, we can see that the series is continuous, and then we can say that the sum, it will be the sum to infinity of a geometric progression with the a equals 0.6 and the common ratio r equals 0.06 over 0.6. So we can get r equals 0.1. Since it is a sum to infinity, so we use this formula a over 1 minus r, and then just substitute these two values, a equals 0.6 and r 0.1. We simplify the fraction, we will get 2/3. So the long decimal number in this bracket has been converted to a fraction 2/3. Therefore, 1.6666 equals 1 plus 2/3, which is equals to 5/3. E2, convert the decimal number 5.459. The bar on the top here shows that the 59 will be repeating 595959 and so on. So we have to convert this decimal number into a quotient, a over b. We did the same thing as in part 1. We have to make it in terms of a geometric series. So 5.4, take it out, plus the series beginning with the 56 means that 0.059 for the first term, and then 0.00059 because the 5 and 9 is repeating, and then we continue until to infinity. So since it is the sum to infinity of a geometric progression with the a from the bracket 0.059, and then the common ratio second term divided by the first term equals 0.01, so the sum to infinity will be 59 over 990. Means that this long decimal number has been converted to a fraction, which is 59 over 990. Therefore, the 5.459 is actually equals to 54 over 10 plus 59 over 990, which is equals to 108 over 195. It should be 5.459.